Hello, and thank you for attending my presentation on detecting COVID-19 in airport traffic with deep learning. My problem statement is quite straightforward. The airline industry has been suffering a tremendous impact from the COVID-19 pandemic. Here we can see the number of flights on March 7th, 2020 at 15,012. Fast forward by 1 month to April 7th, 2020, we can see that number has been cut by two-thirds, nearly two-thirds, at 5,275 flights. Economically speaking, this has had a negative impact on the airline industry, with the number of passengers declining rapidly and the impact on passenger revenues being in the negatives of tens of billions of dollars. We can also see the decline in checkpoint travelers across airports of the US, declining tremendously. To resolve this, I propose using deep learning. Here we can see a schematic of this proposal. A traveler might arrive at the airport and have a risk assessment of contact tracing and temperature checks. Through this risk assessment, if a traveler is determined to be non-risk, they're cleared for travel. If the traveler is determined to be at risk, they have the option of being scanned by a CT scan, at which point a convolutional neural network, which detects the presence of COVID-19 as CT images with a high accuracy, would further assess the traveler, and any positive results would yield further testing. Negative results would clear the traveler for travel. With such a system, we want high metrics for accuracy. For this work, we use the FDA standards for COVID-19 testing, where the recall would need to be above 90% of positive cases being identified. The model accuracy would accurately predict status of lungs every 80 out of 100 predictions. And finally, we would like to yield visualizations that can be useful for medical professionals to identify COVID-19 in patients. The data used for this work was scarce. We had 92 images of COVID-19 affected lungs and 99 images of healthy lungs. While exploring the data, we can see the pixel intensities and the various RGB values for each image. And this data is used by the model to make predictions on the status of the image. The model that was most successful in the work was that of VGG19, a complex convolutional neural network that has had great success in the past in various image and object detection activities. We're able to see some of the activation layers of the model and pinpoint where the features that were of most interest to the model were for predicting the COVID-19 cases. Our model was able to meet the metrics for success with a recall score of 95, an overall accuracy of 90, and an F1 score for positive cases of 90 as well. Our recommendations considering this work are for strategic placement of the CT scans at the proper airports, risk assessment that is effective, utilizing the data that the models are able to produce for medical research and purposes, and expediting the testing with staff that are professional. In future work, we would like to obtain more data and use CT scanning on perhaps intestinal areas or spleen, where COVID-19 is also present, and conduct time series analysis using this data to improve the risk assessment and lower false positive red flags at airport terminals. I really appreciate your time for this presentation, and I welcome any questions you might have. Thank you.